Okay, hello everyone. Thank you for all coming and for joining in for this this talk on unit testing. A huge thank you to Mike as well for agreeing to do this talk. We're going to get going in a moment, but before we do, just a really quick announcement. If there's stuff to do with unit testing and then later maybe with continuous integration and that sort of thing, we're hoping to hold a day on that sort of topic in April. So just make that make a note in your diaries to keep an eye open for that. But I'm going to hand straight over to Mike to give us an introduction.
Yeah, good afternoon, everybody. Let's start with a housekeeping thing. If you have any questions, please use GoToMeeting's chat function and ask your questions. We are monitoring it. So when James will be speaking, I'll be monitoring the chat. When I'm speaking, James will do that. And then we'll decide whether we handle questions immediately or at the end. So yeah, topic of today is unit testing. Let's start with a brief introduction of Consulting Werk, the company that James and I are working for. We're providing IT consulting services to open edge developers. Open edge is the main technology we're dealing with. We're also dealing with related technology, .NET user interfaces, mobile or web user interface technologies, application architecture, and so on. Consulting Werk was founded in Germany, in Cologne. We're having now a subsidiary in the UK and in Romania. We're a team of 12 people now, working with customers all over Europe, North America, Australia, and South Africa. We're providing consulting services, but we're also providing tools, developer tools, a developer framework, other toolkits to customers. And in the context of these toolkits, unit testing is quite important to us. We have a pretty rapid release schedule with those tools. And well, we can only maintain quality and a rapid release cycle through a lot of automated testing, otherwise the risk would be too high. With people in our team that have decades of experience with OpenEdge. My personal experience is 28 years now. I started with version 5, so I've seen a lot of different trends in the OpenEdge world. And yeah, well, with that, let's start talking about unit tests. So short intro on why unit tests are so important to us. Then James will start showing us how unit tests look like, structure of unit tests, and talk a little bit about tooling. And I'll then take over again at the end of the presentation and talk about, well, what are characteristics of testable code, because unit testing is, well, it's a tooling question. You need to know how to write tests, but you will be way more efficient with writing tests when you start writing testable code from the beginning and mocking of dependencies and data as one of the biggest and sometimes most difficult to manage dependencies of code, something that we'll conclude the presentation with today. Yeah, so I mentioned this in the beginning. So we're the developer of developer tools. The Smart Component Library is our framework that we deliver to customers. Well, we need to update the slide. It's used by way over 30 customers right now. We're shipping the source code of the framework to our customers. We take our framework, but we always want to be able to use our framework as a sample of clean OpenEdge code and good coding standards. But it also needs to function. It's nobody wins with code that looks pretty but doesn't produce the right results. We do up to weekly releases, and yeah, our customers depend on the fact that our new releases just bring new functionality but not new bugs. Some of our customers are good enough in producing bugs themselves. They don't need us to help them with that. We have tools that use similar tools involved in the unit testing side that our customers use to update the framework database fully automated, and also that's something that we need to test. And I think with the speed that we're releasing, it's actually a wonder or result of good testing or a combination of both, that we almost had no regression bugs the last 10 years since we're releasing the framework. We have some every now and then, but I think it's all in a quota which is acceptable. And why are we doing unit testing? It's not just because we want to have an insurance against programming mistakes that we do. Every now and then things happen that are outside of the realm of our own code, our own development, that breaks stuff, and we need to fix it. And a very interesting case was there last year in April around one of the Windows 10 updates, the Windows 10 Spring Creators update of 2017, that suddenly broke the input through statement on Windows from Progress versions 8.3 up to 11.7. In this moment, I didn't care whether it was a Progress bug or a Microsoft bug or a combination of both. It just broke a functionality in our framework where we used the DNS lookup utility to verify parts of an email address, the domain. You need to run an MX lookup, and that suddenly didn't return the right result anymore. So we execute our unit tests on the Jenkins continuous integration server. So what James gonna announce for, or has just announced for the April Progress user group meeting about continuous integration, Jenkins is a tool in that area which continuously executes unit tests and other SDLC related tasks. And so when we updated our Windows build server to the latest version of Windows, suddenly unit tests have failed. And to be honest, I'm pretty sure that up to today, nobody in our team would have manually tested the functionality to validate an email address. So if we wouldn't have had a unit test in place that immediately alerted us that this functionality was broken, well, then we probably wouldn't have known about the issue by now. So we have a fix in place for almost a year and a half now, and you can only fix bugs that you know that exist, and that's where unit tests help. In this particular issue, others have run into the same problem with the input through statement. So a couple of days later, there were discussions about the subject on forums, but still then I wouldn't be able to say whether or not we would have realized that we are using this statement and would have been affected by this bug. So yeah, mentioned this already. We don't care who broke this. We just know that our code hasn't changed, but still the result wasn't the same. And that's where unit tests help. We execute our unit tests on a Windows 10 build server. We're having a Linux build server too. The Linux one is a virtual machine actually running on the same physical hardware as a Windows server. As a result of this experience, we will be adding unit test servers on different versions of Windows as well, because we have realized that the result of our Progress code may be, in very, very rare cases, impacted by the Windows version. So what is a unit test? Well, unit testing is a testing method, a software testing method, where you test individual units of source code. A unit is a set of one or more computer programs or classes. And object-oriented programming, we would probably be more frequently talking about classes. And we test that together with control data. Usage procedures is, well, you need to know how that code is supposed to be used. And then you should be testing for common use cases and a little less common use cases. Unit tests may be automated, but sometimes they're unit tests which are very hard to automate, maybe cost intensive to automate. And then a unit test may also be a script where a user or developer or testing engineer uses a piece of software and does the same steps over and over again, each week, each month, each year before you release the software, so that you know that when you do the same, you get the same result. The term unit here is important. A unit should be a rather small unit of code. A unit test is not something like I test my month's end reporting and I want to see whether the right value comes out. In the unit test, we try to break that process up in, probably a pretty high number of small units. Keeping these units small helps you knowing quicker when a test fails where the cause may be. And that in the end helps you being more agile with optimizing your code or re-architecting code, because you know, okay, if I'm going to change this bit here, this is going to be monitored by a number of unit tests, and if one of those unit tests fails, I'm pretty sure that I know which code is broken by that. So that's the whole trick, to know when you change code or a unit test fails, that you have a pretty close scope about what might be failed. So automated unit tests have many advantages because it's much cheaper to let a computer execute all those unit tests hourly or nightly or whenever you commit code than having human users doing that once. And the idea is that you write tests once and execute them for the lifetime of the software product that you're working on.
Okay, so thanks, Mike. We're going to have a look now at a simple unit test. I'm going to be working in Developer Studio to show this. The reason why we use Developer Studio for it is because Progress have included some tooling called ABL units within Developer Studio, which makes all of this very simple to do. So I'm going to switch over now to my Developer Studio. And the first thing that you need to do in order to unit test within Developer Studio is to make sure that the project is enabled for unit testing. So up on the menu, you go to the project menu and go to properties. We have here an option called project facets. And here within the project facets, we have an option called ABL unit. So if you want to unit test within Developer Studio within your project, then you need to make sure that that checkbox is ticked and you hit OK. There's also a perspective in here as well. So when we go to the perspectives view, we have an ABL unit perspective as well, which means that that essentially opens it up in a perspective specifically for ABL units. And that includes down here at the bottom also a view for ABL unit results. I'm running 11.7.3 as my release. Do you know when ABL unit was introduced? Was it the start? Was it in 11.6 or?
I must admit, I'm not 100% sure. It must have been between 11.5 and 6.
Yeah.
11.6 integrated the profiler, which was added on top of unit testing, so it might have been 11.5 where ABL unit was made available.
The point being that that we need to be in a reasonably modern version of Progress in order to do this. This is 11.7.3. It's certainly available in 11.7 and certainly in 11.6 as well. So let's write ourselves a unit test. On my screen, we've got a very simple procedure. It takes a couple of input parameters and an output parameter. Checks that the second input parameter is not a 0 and returns a division of the two. So very simple procedure, and we want to create a test for this procedure. So we can go to File, New, and we have here some test cases. Test cases, 2 types of procedure in a class and a test suite class. We want to create a test case, and I'm going to create a class because that's what I'm going to do. But you could create a procedure if you wanted to. So my class is going to be called division test. It's always useful to know from the class name what you're testing, so that it's easier to check. You can even down here where it says the class to test, you can also include a class that you're actually going to be testing there, and it will also provide you automatically all the stubs from that class and so forth as well, to save you having to type it in. In this case, we're going to be testing a procedure, so we won't do that. So we just call it division test. And I'm going to keep it within my unit testing package, but in a subfolder called tests. We like to keep our tests separate from our code as much as possible, but there's no reason why you have to do that. That's up to personal preference.
In the end, you could, in principle, also include your unit tests in the production code that you're about to test. But James and I both think, well, it's going to clutter your code. When you look at the code, well, unit tests don't need to be executed in production, so why include it in the production code? And they may have different criteria, different coding standards, so I'm really not a fan of including tests within the actual code to be tested.
There are a couple of cases where we'll look at later where there's one case in particular where it's imperative to include it within the code itself, but we'll get to that in a bit of time. So we've got our class here called division test, and the first thing I want to do is to test that the division function actually works and provides us with a valid result. So I'm going to add a method, and we're going to call that valid division, like that. Quite simple. It takes no parameters. We're not allowed to include parameters in methods or procedures for unit testing. And I am going to define a variable for the results. And quite easily just going to run my division.p. And I'm going to give it a 15, a 5, and output DE result. So essentially what I wanted to say is, give me the division of, do 15 divided by 5 and give me the result, the DE result. Now we know that 15 divided by 3 is 3, should be 3, hopefully. That's what we're wanting to test. So there's a class called assert, which lives within the OpenEdge core product. So it's a class which is shipped with Progress Developer Studio, called assert, and it has a number of internal methods for doing assertions. In this case, we want to do an equals assertion. And we'll have a look at how we can see what's inside this class in a little while. But we just want to see whether DE result is equal to 3. And there we go. That's the method written. That's a quite simple unit test. We are going to assert that our result is equal to 3. Now we can run that very simply from here. We do a run as. Yeah, Mike's just pointing out that I'm missing something as well, which I just noticed as well. We have an annotation called @test. This tells Developer Studio or ABL Unit, tells it that this is a test method. It's important to include those, or else you have, well, it doesn't work. There are other annotations as well, which we'll look at in a few minutes' time. But for now, we can just run our configuration as an ABL Unit application. That goes off and does its thing. And we see down here in the ABL Unit perspective that we have here our valid division method, and that has completed successfully without an error. So we have asserted that our division operator is working correctly. In fact, if I could go back to division.p and I could do something really silly, and I could just add a 1 onto the end of there, and I can go back to my division test class, and I can, if I rerun this again, we'll see it's not very happy. It says that the result we're expecting was a 3, but we actually expected we were expecting a 3, but the result we actually got back was 4. I got my parameters the wrong way around. That's why the message doesn't make sense. That's simple. Perfect, there we go. Helps to prepare these things in advance. I'll rerun it just to make sure. So there we go. We're expecting a 3, but we actually got a 4. Let me just put that back to what it was before, otherwise we're going to get ourselves confused. The other thing, part of our division.p that we have here as well, is that we're trying to throw an error if we're passing in a 0 as the second parameter. So we can also test that error is also thrown. So let's add another method, and we will call it division by 0, and we'll generate that. And this, and we, again, mustn't forget to put the test in, but in this case, we will tell it that we expect it to give us an error. And we're expecting a progress.lang.app error from this. And whack a full stop on the end of there. So now we can have our result variable, and then we can run our code. And we'll make sure we put in a 0 as the second parameter, and there's our results. So if we save that, I will rerun it. And we can see here with the division by 0, it's quite happy. It's received the progress.lang.app error back from the program. If I comment out this bit here, the bit that traps that error and throws it, and rerun it, we now see that we have a failure on our division by 0. There's no exception raised, but expecting a progress.lang.app error. So we can see that if something changes now in our .p file that we're not expecting, the unit testing will pick that up straight away.
When we look at this very, very trivial program, the requirements for this program might have been that when you provide 2 valid numbers, it should return you the division. And the second requirement is that if you pass in 0 as the divisor, it should throw an error. So with the unit test, we're making sure that these 2 requirements are fulfilled by the code. And therefore, we are writing 2 test methods for a single procedure or method in this case.
So yeah, that's great. Now another little thing that we have here, so we have the 2 methods, the 2 test methods that we've executed, and one of them's failed. We've worked out what the problem is for the one that's failed, but we don't really want to run the whole test procedure again because well, valid division could take hours and hours to run, maybe, for example. So we just want to double check that our one that we've changed is run completely. It's running completely fine now. So I've got my division by 0. I see that it's an error. And down here on the right-hand side, there's a little run icon here, and that will just run the selected test again. So now it's run again, and we can see it's only run division by 0, and we can see that now that it's running completely fine. So that's a useful little test if you've just got one test within a whole suite of tests that you want to rerun. You can run it very simply from there. So we'll have another look. We're going to have another look at something a little bit more complicated. Again, we've got here a simple class which holds sales price information, and we've got a price that comes in as an input. So this is just holding the information essentially for this particular sales item basically. And we have a service here, another class with a method called sales price info, called calculate sales price, which returns the sales price info. And we have a number of stuff, but it finds an item from the database, it finds a customer from the database. It does some extra stuff, and essentially it just returns an object where we have the price multiplied by the quantity, and then we've also got the gross price, the discounted price based on the customer discount, and the gross price for the whole order as well. So that's quite simple. Quite simple in itself, but it's a bit more complicated. We can see there's multiple classes involved. But we can test this. We can break this down. I've written this one earlier because it's quite a lot of typing to do otherwise. But we have here a test class. And first of all, what we want to do is to test that the prices that are returned from our class are actually what we expect. So we can new our service, and then we can calculate our price for item number 1, 10 units, our customer number 1, and we pass in a date. And I know from looking at the database that the answer to this question, to these inputs, should be 24 for the price, therefore 240 for the gross price. But with a discount for that customer, that's what our discount. That's the price, and therefore the gross discounted price is £156 or whatever. And we can do our clearing up with the garbage collector or whatever, however you want to implement that as well. Now, obviously, we can see straight away that there's an issue here. We're relying on data from the database, and Mike's going to talk about how we mock dependencies such as data and so forth, and other classes later on in the talk. But for now, I'm very heavily reliant on this record actually being correct and having that data in it.
So with the numbers that we see here, the 24 to 40, 15.6 and 156. As a developer, in an ideal world, the requirement that you have to implement, the user story that you're working on, whatever, the business analyst would have provided you with some test cases. He would have said that in our reference database, the price for item number 1, 10 items, and customer number 1 on that date would be this. So that you know, okay, well, the business analyst probably has used his pocket calculator and knows what the output is. So that should be the result. In a situation that we are very often involved in the case of modernizing an open edge application, so we're taking a monolithic character or TTY or graphical application, fed client server, whatever, and turning that into a N-tier application, maybe with a .NET front end or a web front end or a mobile front end, then very often the reference data would be coming from the legacy application, and we would be picking an item and a customer, and we would just be checking, well, what did the legacy application do? Because in those cases, very often the requirement is that it should just return the same numbers as the legacy system. And but either way, yeah, the developer should have some indication of these values, and well, yes, can we depend on the database then to provide us the reference data, but we'll talk about that later.
Yeah. So we've also got a few other tests in here, and again, I'm doing another test to check that we're actually receiving an exception, but in this case, it's a custom exception called invalid parameter value exception. I'll have a quick look at that sort of thing in just a moment or two. And then we also have a different way of dealing with errors as well, actually looking at the error itself that's returned and handling that depending on the type of error that's come back. So that's just a couple of things. I think probably more importantly, just at this point, probably to sort of have a look at the assert class that comes with the Open Edge Core product, and have a look how we can see what's actually going on inside there, or what's available to us in terms of methods. So you have a class browser in Developer Studio, and that's a view. And if you go to the window view, you can see the class browser there. And in the top here, you can actually search for your class that you want to have a look at. And down here, we have an openedge.core.assert. And then inside here, on the right-hand side, you can see all the different methods that are available within that class, along with what sorts of inputs and outputs it's expecting, and that sort of thing. So we can see that we can do, there's a number of different types of equals, so we can check basically that various data types match each other. We've got things like has a determinate extent, so that's essentially looking at to see whether a variable has an extent set. Is it an abstract class? Have we got a record of a widget handle available? Is something a decimal? Is something empty? Is it false? Is it final? is it an int64? Is it an integer? Is it negative? So you can see there's a huge array of various methods that we can assert. So it's not just that we can't just assert equals. There's a not equals as well. We can see whether something is 0 or negative. So we've got a huge array of things in there. But we also can write our own assertions as well, if we want to do that as well. But that's just a quick aside to show this is where you can go and find out what's available.
The method name is always what you expect. So if it's not null or empty, you expect that a character value is not empty string or not unknown value or something like that. Which means if it is unknown value, the assertion method would raise an error.
Mm-hmm. And in our division test here as well, once I'm talking about a couple of things as well, we tested here for progress.lang.app error. That's actually pretty bad. You can do it, but a progress.lang app error is any error that you might possibly have returned to you. So it doesn't guarantee that it's actually the error that we're looking for. It's much better to use much more specific exceptions, and in fact you can create your own exception classes as well. And this is what we had in our test class here. We had, if I can find it, we were looking for an invalid parameter value exception here, which is one of our exception classes, but they're very simple to set up. And so forth. So actually, then you can actually test for specific errors being thrown around, rather than very generic ones. So I think we've been through all the very basics of how to write very simple tests. I've had a couple of extra bits as well, but we've done our simple tests.
Let me mention one brief thing. When you start using unit tests, I mean, every developer writes code, and sometimes you have code that, well, can only be tested through UI, but when you write calculation routines, APIs, or whatever services, then very often a developer has to write a test procedure that you may even just be executing as an ad hoc procedure from the procedure editor. And then you instantiate a persistent procedure, you run an autonomous procedure, and then you have a couple of messages to show you the result. And these ad hoc .ps to test these processes, they are wasted time, because in the same time you could be writing the same stuff as a unit test with the assertions for the result. And while writing a unit test, you can also use message statements in the unit test. But at the end of the day, when you've written it as a unit test, and it's basically just an empty message with the @test annotation, then you have reached the reusability that allows you to re-execute those tests on your integration server once you set one up. That's not something we're going to look into today, because, well, try to be not much longer than an hour today. But an ad hoc procedure that you hack into the procedure editor, you should get into the mindset of, well, that's a waste of time, and it's much better that you start writing a unit test from the beginning.
Yeah. So let's have a quick look at the structure of a unit test. So first of all, unit tests are not exclusive to the ABL world. We had a look that you can test procedures. You can also write you can have test procedures themselves as well. So they're not exclusive to the OOABL world at all. At the same time, it's the OOABL world lends itself a lot better to unit testing, because by definition things are a lot more broken up into sections, into units, essentially, so they're a lot easier to test. And a unit test is a method or an internal procedure which executes a piece of code and asserts the expected result of that code. So that's what we've seen. And we can include them within the compilation unit that we're testing, or we can put them into a separate class or a procedure file and keep them separated from deployed code. And as we said, that's our preference. Unit test classes and methods and procedures do not have parameters. They may not have them. They will break. They won't run without them. And we have the methods annotated with the @test annotation. We'll have a look at those again in this. Well, we're going to have a look at those annotations now. So unit tests are all driven by annotation. If you haven't got an annotation, then the unit tests, ABL units doesn't know what to do with them. So we have to have the annotations there, and it's documented. We'll send slides out after the talk, so you can take that link. You don't need to write it down now, but there's a link there for where it is in the documentation, because you do have to go digging a little bit to find it.
The thing with the annotations, most ABL developers may not have seen annotations before. Technically, annotations are a statement, which is a bit confusing. I refer to them more like a technical comment, because it's not really an instruction that is to be executed. It's more like a logical an ability to provide meta information about an internal feature or a method or anything else. Well, the ABL makes use of them for REST interfaces of classes and for unit tests. And well, in the future development of the ABL, I'm also expecting more use of annotations because they're heavily used in other programming languages for all sorts of declaring how classes should be used or methods should be used.
Yeah. So we have essentially got, for testing, unit testing, we've got 6 annotations and 1 which is kind of an expansion on the previous one. So we've got the test one that we've already seen, and this identifies this method or procedure is a test method or procedure. But then we've got a couple called setup and tear down. Setup executes this procedure or method executes basically before each test is run. So you can use this for initializing things that you need for each test to work. Teardown is the kind of the opposite of that one, it runs at the end. And then we've got before and after. Before happens right at the very start of this test procedure, and after happens right at the very end. Those two happen only once. So the difference between setup and before is that setup happens before each test, and the before one happens right at the very start only once, and the same for teardown and after. Then we have the ignore annotation, which essentially says, ignore this one. You might use this one if you're still working on the code behind the test. So if you've written your test before actually writing the code, which can be quite a good practice, can help you to understand that your code is actually working. But if you've done so and you haven't written the code yet, then obviously that test is going to fail. So you set it to ignore. And it may also be used if your test is going to take a long time to complete. Sometimes we don't want to run all the tests, so we set some to ignore because they take too long.
I must admit, I don't understand the use of the ignore, because you can just take the add test annotation and put that in comments.
Yeah.
It's going to be the same.
And then we have the expansion of the one there at the end that we saw, where we test for a particular exception at the end. The one thing that's really important, there's a tiny little bug in ABL unit. You have to have a full stop at the end of your annotation. So this slide is a little bit misleading. There should be a full stop at the end of each of the annotations. But if you have a space before the full stop, before the periods, then ABL unit ignores that annotation as well. And that's been logged as a bug, but it's just something to be aware of. So make sure you don't have a full stop, a space before the full stop. So we saw briefly the assert class from Progress, the OpenEdge core assert class. And it's a simple way to test that a value received by the tested method is what we're expecting. They're static methods. That means you don't have to new those methods. You can just use them. And they're a single method call that tests a value and show an error when the value does not match what you're expecting. You just fire and forget them. So we've had a look at the OpenEdge core assert. For our customers, we also have the consulting work assertions class, which has a number of various other assertions in there. And alternatively, you can roll your own. And I'll show you how simple it is to roll your own right now. So I have, in fact, within our price calculation class, we also have a little method that finds the item that we want and returns the category. It doesn't really belong in this class, but it was the simplest place to put it in terms of this demo. So essentially, that just returns the category 1 for an item, and I want to test that that is correct in a case-sensitive manner. Now, there isn't a case-sensitive equality assertion within the OpenEdge assert. And so I've created my own assertions class, and I have created an equals case-sensitive assertion. And so let's have a look at that quite quickly. So here we go. Here's my my assertions. It inherits from assert, which is the OpenEdge core assert. So it kind of that ties it together. It says that all the functionality of the OpenEdge core assert is within it. But it also has my specific method in there as well. So I have my equals case sensitive. It takes 2 character values and it checks that they are equal to each other with a case sensitive compare. So here we have a compare, and we're checking that they are. Well, we're looking to see if they are not the same on a case sensitive compare, and if they are not the same, then we throw a new app error with the value does not equal. So if we have a look at our test again, so here we go. I know that that will fail because it's diving with a capital D. So here we go. I've run my test case, and we can see down here in my test case that value diving does not equal diving. So it's very, very easy to, as I say, to create your own assertions. You can create an assertion for just about whatever you can think of. So if there's not one within the libraries that you have available, it's very simple just to add one in. And so let's go back to here we go. And oh yeah, that should be there. The other thing that I want to quickly mention as well is that, so we talked about having your test cases in separate classes and keeping them separate from your general code as our preference. There's a couple of situations where that's not a possibility. So a separate class only has access to the public methods within the class to be tested. And you might think that just changing the classes, the methods to public so that you can test them might be the way forward. That's a bad idea, particularly if you forget to then put them back and then set to protected or private for a particular reason. Then you've broken something within the security of the application.
Or if you suddenly make a method public, you may have to support it for the rest of your life because your colleagues will suddenly call into that public method, and it was meant to be an internal method that you would want to reserve the possibility to change it as needed in the near future. And once it's public, you have to take care that nobody else's code is going to be broken, because maybe renaming it, you may be adding parameters, you may be removing it, and so don't make things public that are not required to be public.
Yeah, so there is a solution. If the methods are protected, then your unit test class can inherit from the testing class itself, and that way we can use the methods. If they're private, then you, or if they're protected as well, you can include the test methods within the actual class as well, and that gets around that. In practice, you'll probably do some sort of combination of the two. I'll just have a quick look at some code just to show you exactly what I mean with that. So I have a protected class here. So here we have our method. It's calculate VAT, and it's a protected method, and it does some stuff with some calculations and so forth. It doesn't really matter what it does, but it's protected. I want to test that in an external thing. So my method, my class to test the class has to inherit from my class, or else it won't work. So if I comment out the inherits from here, we can see that this doesn't compile. it doesn't know what this calculate VAT method is because it's not available to it. So I leave it as an leave it to inherit it, and the compile errors go away, and I can execute my unit test. My unit tests are working fine. If, on the other hand, I change my method to private, as we talked about, my protected class test now will not compile. Again, it can't find calculate VAT as a method because it's not available to it. So in this case, as I said, you can create methods within the class itself. So here's our private method, and our test annotations go within the class itself, and now we can test that our VAT method is working correctly. And again, here, if I run as ABL unit application, we can see that my calculate VAT to test internal and test invalid VAT internal both completed successfully without any errors. So a quick note about unit testing tooling. The most important piece of tooling that you need for unit testing is structured error handling. If you don't understand structured error handling, then now's a good opportunity to go ahead and read up on it, do some learning on it. But if you're not throwing your errors around properly, and if your error handling is not solid, your unit testing will be doomed. You'll really struggle. Unit testing can't trace errors that aren't thrown far enough up the stack. It's just not able to do so. So make sure your error handling is robust and that you're using the new structured error handling that's available within Progress. We have already seen ABL Unit. ABL Unit is the unit testing tool that's integrated within PDSOE, and it's great. It works really well. It's very simple to use, and that's great. There's also proprietary unit testing tools for ABL. So we've got Pro Unit, OE Unit, and we've also got our Smart Unit, which is a component of the Smart Component Library, which is available to our customers. They're all very similar, but different in the detail. So if you don't want to use ABL Unit, then you can look into those other ones yourself.
One of the most common reasons for not using ABL Unit might be being on an OpenEdge release, which does not support it yet. That was actually the reason why we started developing our own unit testing tool around version 10.2a or 10.2b of OpenEdge. We added a few features to our unit testing tool, which are very specific to the way we write applications. So this is why we keep on maintaining our own unit testing tool. But actually in the developer studio, we are using ABL Unit, and on our integration server, using our own unit testing tooling. They'll inherit a lot of standards from JUnit, which was like the first of the modern unit testing tools. So, and that's where a lot of the standards come from.
Yeah, that's this slide basically. Yeah, so most of it inherits from JUnit. The use of the annotations and so on is a JUnit thing. There's also an output file of the tests, which is a JUnit de facto standard. So if we have a quick look in here, we can see here there's a results.xml, and if I open that up, that's the result of my unit testing, which is just a simple XML file, and we can see that it's the same calculate VAT test internal. It's exactly the same as whatever the last test was that you ran, and it's a standard format that it contains. It doesn't look very pretty because it's machine generated, but you can prettify that very easily and see it's a standard XML file and has all the information about what you've done. And that's where continuous integration tools such as Jenkins and that sort of and those sorts of tools come into their own, because they're able to interpret that XML file and see whether the tests were successful or not and act accordingly. There's no formal definition for the XML file; it's just a standard that's sort of undocumented. Mike.
Okay.
You have 10 minutes.
Well, I'll exceed a little bit. So let me take over the presentation. writing testable code. James mentioned already, testable code is not limited to new object-oriented code. Procedure files can be unit tested as well using ABL unit. ABL unit allows you to write class-based tests that test procedural code, but also procedural tests that test your procedures. However, the nature of many ABL procedures is they're very long. They do a lot of stuff. The concept of thinking of small units of code hasn't really been the strongest part of procedural ABL programmers. Most of them, maybe you're all the exception, but many of them that I've worked with have written a couple of 10,000 lines of code in procedures and internal procedures with thousands of lines, and that code is difficult with testing because it's monolithic. In order to be successful with testing, a very, very important concept is the concept of mocking of dependencies. And again, object-oriented thinking brings in the term of dependencies. What is a dependency? Dependencies are other pieces of code that code calls into, that code requires to perform its work. And when you execute a piece of code that has many dependencies, and the code doesn't do what it's supposed to do, you still don't know whether it's your code that's wrong or one of the dependencies that you depend on is wrong. So dealing with those dependencies, and we've seen in our introduction, these dependencies could in theory also be the Windows version that you're executing on. That's actually the biggest challenge of unit testing. It's not so much writing these tiny test classes. That's actually something that doesn't take that much time. It's managing dependencies. And this idea of the thinking of dependencies and being able to abstract them, that's just a more common concept in object-oriented programming. So that requires more an object-oriented mindset of abstracting things and understanding concepts such as interfaces to a dependency, and then, in the end, being able to replace a dependency for the purpose of testing with another bit of code that has the same interface, but is so simple implemented that it cannot fail. So if we think about a huge financial report or invoice generation, those are typically barely testable in YOL. They may be large, they may call many subroutines, and when that fails, well, what is the cause? You may not know that. It may be a bug in your code. It may be that the numbers that the business analyst has given you as the outcome of this invoice were just wrong. His pocket calculator had a bug. You might have had wrong data in the DB. And what might be the output? The output of an invoice generation might be a PDF file. And maybe even an encrypted PDF file or a signed PDF file. And how are you going to assert the numbers in that PDF file? It's very difficult to programmatically look into the PDF file and say, oh yeah, that's the right amount in the end. So what can we do with that? Well, we can break up that report or that invoice into smaller components and then test those individual components. And also have a test that tests the whole thing at once. So we could try to break up such a report into the piece that gathers all the data and computes all the numbers. And instead of immediately producing the printable output, let's convert the code so that it produces data in a temp table first. Because then it's very easy to investigate the data for correctness using ABL methods. And then you have another module that takes this temp table as an input and produces a PDF output out of that. In the end, testing whether the PDF is correct is very difficult because it might have criteria for formatting the data and so on. But then at least you know that all the business logic that gathers all the data and is intact. And if you look at typical programming requirements, probably the requirements to change this report in the future or this invoice in the future is either There are new requirements on the content, on the numbers, on how numbers are generated. You may have a new customer where you have a new discount calculation rule, or on the formatting, because the company logo has changed and now you need more space on the invoice header for the graphics and you need to rearrange all the text. So you've broken up the risk into, well, I either change code that works on the numbers, or I change the code that does the formatting into 2 bits by separating the 2 parts and using a temp table in between. So that would be a very simplified example. The devil lies in the detail, of course, but that would be general recommendation. James mentioned error handling, very, very important. You must throw errors. If you're on a semi-reasonable version of OpenEdge, so everything beyond 11.3, all new code should be using the block level on error undo throw. And there may be some exceptions, but we don't have time to deal with them. You need to make sure that when an error occurs in your code, it is thrown so far that the unit testing tool can gather it. The ABL, the standard error handling in the ABL, is based on blocks, and loops can be blocks that have error handling criteria. And if you would have like a for each block that works on a couple of thousand errors, a couple of thousand records, and within that loop you run into a runtime error, like you're trying to dynamically open a query but the handler is not valid. I think everybody knows that well, you may end up in an almost infinitive loop of where you have to click OK a couple of 100 times to get over it. Well, in unit testing, it would have been nice if the first error of that would have already thrown to the test tooling and would have reported you that there's a problem with that code. If that doesn't happen, if the code isn't thrown, then the unit testing tool might tell you, oh, this code is working fine and there's no error. And these errors are basically buried in the log file of the test framework and not traceable. So structured error handling is very important. So let's have a look about mocking dependencies. And I'm going to work here in the next 2 sections towards mocking the data access that we have in the code. So generally, writing unit tests is a permanent fight against all those dependencies and against the bugs in them. And as a developer, you want to be prepared to say that if or you don't want to be in a situation where if your unit test fails, you're generally the first person that's being blamed, and you don't want to be in a situation where after 3 days of debugging you find out it was a colleague of you who is currently on vacation. You want to be sure that when your test fails, it was your work that was wrong, and then you take the blame, and then you fix it, and then you take the honor, not the blame, you take all these thanks for fixing it. So if we look at the price info service, James had database access there. In modern application, we don't want to do that. We don't want to see database access in business logic. That should all be coming through business entities. That's an architectural discussion. That's also a bit out of scope of this talk. And then there might be 2 business entities that the price info service might rely on. That's the customer business entity and the item business entity. So instead of dealing with the database directly, we may have an inventory service that might also be required to tell whether we actually have the items on stock. There might be an authorization manager of the framework that might be involved, that might be checking whether a certain sales rep is actually allowed to get a price quote for a certain item and so on. So these systems tend to get complex, and when the test fails, you don't know whose fault it is. And the other thing is, well, we may want to test how the system reacts when we don't have items on stock for that, or when we have a lot of items on stock. Maybe that has influence on the price. If all the data comes from a database, then it's very difficult to test for these extreme situations, because you always need to be maintaining data in a database that's providing you these extreme situations. So when we are mocking these dependencies, we're using mock objects, and mock objects, that's a term for objects that mimic the behavior of an actual component. So programmers create these mock objects to test the behavior of another object. If we take vehicles as a pattern here, the crash test dummy that you put into a vehicle and to see whether a human would have a chance of surviving a crash in a car, well, that's a mock for a human in the context of that unit test. You want to test the car, but you don't want to do it with a real human. These mock objects simulate the behavior of other real objects. They may be complex or more or less complex, that basically allows you to test individual pieces of the puzzle. The idea is that these mock objects are written so simple that they hardly can fail. So that requires, and now we're really getting to the point where thinking object-oriented mindset helps. If we look at a piece of code that runs a procedure and you have a run and a .p there, then you're calling another piece of code. So you're basically calling a dependency. And in order to mock that dependency, you need to abstract that run statement or viewing of those objects. So you only are able to mock these objects when you have a tool at hand that allows you to configure outside of the code to be tested who is providing the required functionality. So that in the test scenario, you can configure that we're actually not using the real business entity, we're using something simulated, or not the real database access, we're using something that simulates that. And that requires tools or typically framework components like dependency injection, or the service manager from the common component specification. The common component specification is a set of specifications for architecture components that Progress Software and some architects from the community have defined 2 or 3 years ago. And one of those initial components that we worked on is the service manager that allows this. And I'll show you in my code how that works. Actually, here's the slide. And instead of going through the slides there, I'm going through the code there. So I have the same service here for the price calculation that James was showing earlier, where we have the 2 finds. And the dependency here is the database, and the database is a very, very ugly dependency to manage. I very often hear from developers of Progress ERP or financial application whatsoever, that in order to test the code, you need a gigabyte of a database of a couple of gigabytes size. And then for extreme cases, if you want to test how your code behaves with the average data, good and bad data, you might need 3 different variants of the database with each a couple of gigabytes in size. So that's very difficult to simulate. So what I'm going to do now, and that's maybe like the scenario of re-architecting something, I'm going to test whether the unit test of the price calculation service works, and it's being executed right now. And it will come back with the right data. I'll show you in a second why it takes a second longer. That is basically because we're simulating an application framework being loaded in order for the test to succeed. So all the tests have come back successfully. So now I'm going to comment out that test method, and I'm going to take the alternative variant. And if we look at that code, then we will see that I have references to 2 business entities through interface types. If in OO you start talking about abstracting your dependencies, then the logical next thought is that you think about having interfaces. So when I want to communicate with the item business entity, sorry for that, then I'm going to ask a component of the common component specification, the service manager, to give me something that is configured to be the item business entity here. And then I can run a request against that. The alternative to that would actually be that I'm doing item business entity is new item business entity. And now I have the problem that I'm always depending on that specific business entity implementation, because I'm deciding here in my code which it is, and that disallows mocking. So mocking always requires some mechanics in place to abstract the code. And so we're now translating the code to use a business entity instead of a direct database access. And so now we've refactored the code, so my business logic to use business entities. So I'm executing this unit test again. And well, the least expectation would be that the modernized code returns the same data as before. So the unit test will help me with that. And while that is executing, we will see when the result comes back in a second. I haven't made any changes to the test that James showed you, to the actual test methods. However, what I'm doing is I'm using the before test method, so the method that is executed just before all of the test methods in that class, to verify if in this session that I'm using for the unit tests, the service manager component, which I'm using to get access through to the business entities through configuration, has already been started. And if not, then I'm invoking the startup procedure for the framework. So that's the thing which now takes a couple of seconds extra. And of course, we could create a more lightweight session configuration that would be a little bit faster. This is now actually the full-blown application startup that I'm doing here. The only thing which I'm not doing is authentication. But point is that when I get access to the business entity here, I don't know, the line above, I actually don't know and I don't care about the actual implementation of it. I just say, well, I want something that is either the item business entity or a replacement of it. So let's move on and look at what we're doing with the data. Well, we're using the ABL typically to build applications that deal with data. ABL is very rarely used to build applications that don't have huge dependency on data. That is a good and a bad thing, but yeah, that means we have to deal with data. So the functionality of the application is dependent on data, typically in the database. And as I mentioned earlier, database is a difficult to deal with resource. So our tests may rely on stock data or price data in the database. And you wouldn't be the first one to whom it happens that suddenly a unit test that was working fine for ages fails because another developer has implemented a unit test that tests for the successful deletion of your standard customer. And suddenly all the tests that expect this customer to be in the database will fail. That's just a very, very simple thing that can fail. And the same is with modifying data. You might just change the status of an item and suddenly it's no longer available for the price calculation or whatever. Yeah, all these things are difficult to deal with. So there are a couple of ways how to deal with that. If you have a good control about all the tests that you're executing, there's actually nothing wrong to execute unit tests in a nightly test sequence against the database. You should then restore the test database before the sequence, or build a database using automation tools such as PCT each night before you're executing your tests from a set of standard D and DF files. And so that you know that each time you begin your test sequence, you have the same start point from the database. If you know that you have tests that actually manipulate customer or item data heavily, and then you have another set of tests that rely on certain values, then you might have to rebuild that database a couple of times during a test sequence. So that's something which requires some planning. Bigger development teams doing test-driven development very often have test managers, so that are really developers which just deal with automated tests. In the end, you can do that. It requires some management, produces lots of disk I/O. On our build server, we just noticed every time that the disk I/O on the SSDs of the build server, and it's using a array of SSDs. The actual disk throughput when dealing with the databases, that's the actual bottleneck on our test server. So if we could improve the speed there, then our tests would execute faster. And if you execute tests not at night, if you execute your tests after each commit of code, it might actually make a difference if a developer knows that the code that he has changed breaks something or not. If he knows that after 15 minutes or 45 minutes, because after 45 minutes, well, you're already working on something completely new, and you've already forgotten about the code that you've changed an hour ago that might have broken something. You can solve this with transactions. You can put tests that manipulate data in a database into transactions and undo those transactions at the end. So if you have a test that tests whether you can delete records, you could actually wrap that in a transaction block, execute the test that deletes, including all the validation that goes with it, and test whether the record is really gone using a simple can find, and then undo the transaction in the test class. That may have side effects too, because the code that you're testing may actually be depending on a very specific transaction behavior. So that's not always a solution for everything. Depending what your code does, it might require your transaction scope. You might need a big log table and so on. So transactions is also one of the things you need to be very sure that you understand your code before in the test class you wrap it in a transaction. And the other thing which we do, and that is now heavily dependent on the architecture that you use in your code, is you might mock the data access. Again, there are many suggestions on how you could write data access following the principle of the OERA, the Open Edge Reference Architecture, and following the principles of the CCS, the Common Component Specification. If you do that, and again with some OO thinking, the price info service is accessing an item business entity to get item data. And not even the item business entity should be aware that there is even a database. The item business entity talks to the item data access class. And the sole purpose of the item data access class is to have a single place for query optimization, but it also allows you to have a single place where you could mock the database, replace access to the database with getting data from XML files, for instance. And that's what we're doing. And before we go into the questions, let me show how we have solved that and show how that may help you. We have some tooling that helps us to build business entities. So that's our business entity generator, where we can use drag and drop and design these business entities, which should be the main data access components, or know how to deal with that. And we have a testing utility that's basically an ad hoc query utility. I could now run queries against a business entity to look at the data, so which is now the status quo right now. And we've integrated into this the ability to create a data access mock. So we're saying, so this is data that the data access class is returning to queries. So I create a mock of that, and I select a folder where to store that to. and I typically store that in the folder with the unit tests, so the item data access mock and the data files. So there are 2 files that will be generated. And if I look at those 2 files that now have been generated, one is a JSON file, and the other one is an XML file. So this XML file here defines or shows me the data, and this other file, use the wrong business, let me quickly fix that. This other file says that if we're testing this item data access class, if that's being used, we're not seeing where it's being used because it's being used from the business entity that we're referencing. Use the data from this XML file instead of the database. So I'm not going to change any line in my price info service because that's already dealing with the business entities. I'm just changing something in the initialization of the test. And we initialize the mock of the data. So that's the tooling that we built for ourselves from this simple unit tests item data access.mock file. So that's the data I want to use here. And then I'm going to re-execute the test. And we see it still returns the right results. Okay. So now instead of changing the data in the database, I could change the XML file and say, well, what if the price is 25? And I rerun the test again. Now I'm expecting the test valid price to fail. The other test should actually still be returning the same result. So now I see the test valid price is failing. It was expecting 24 as the price for one item, but now the same code has returned 25 as a result of different data in the database. Well, as a result of different data, and I didn't have to modify data in the database for this. So what I did to get back to that picture here, we have the price info service, the unit that we want to test. We know it depends on the item business entity. The item business entity depends on the item data access, and through configuration, so I just loaded a JSON file that references an XML file, so that's configuration. We're now reading data from a JSON file, and now in a test sequence, I could now very easily reference 3 different of these JSON and XML files to simulate 3 different statuses of that database table, and that's greatly simplifying working with data and unit tests. So we're coming to an end of this afternoon session. And I would say we look at questions. There are no questions in the chat. If anybody has a question, please type a message in the chat, and then we can either just answer that question or we actually open your microphone so that you could be that we could be having a discussion on that. But if there are no questions, we can also leave questions for email. James' email address is in the presentation slides at the beginning.
yeah, we'll send out an email to everyone who's been taking part. We'll send out the slides and so forth, so you've got those. And yeah, I think that's it. Well, thanks everyone for coming. It'd be great to hear some feedback. Actually, I'll mention it in the email as well. But if this is the sort of thing that is useful, then we'll certainly look to try and do them more regularly as well. But thanks for joining. Thanks for coming and taking part. And yeah, that's it. Great. Thanks everyone. Bye bye.